Welcome to Callous Coder. Today we're going to have a hardware resuscitation session. Motherfucker! The other day I was playing on my Apple IIe. I was installing Merlin on the floppy emu that we just reviewed. And as I was coding I heard tss. I think, what is that? And then I started to smell something. I looked at the rear and a nice puff of smoke came out of his ass. It is still running, but I'm going to see what it is and we're going to fix it. I assume it's a capacitor, or it could be a small resistor that burned through. So let's get right in. First, take off the hatch. And we have to undo all the screws on the back so we can lift out the power supply. So it is still running, but I don't want to risk continue working on it knowing that something has been literally smoldering in there. All the screws are out. There's the keyboard cable. We're going to disconnect it for now. I'm not going to be using that. There seem to be some death-friendly animals in here. Oh my goodness, look at that. So now we can throw it over and remove the power supply. Oh yeah, it definitely came from here. Let's open it up and see what we can find. Well, that definitely is the culprit. Look at that. Now I just came across a little problem. All these screws have marks on there. And when I unlock them, I am actually afraid that I void my warranty. The strain relief is extremely stuck, so I am forced to use pliers. Not really something I want to do, but poorly designed power supply. Usually if you turn it a quarter, you can lift this up and get the cables out. And there's a flat piece and a rounded piece, so that's why you turn it, twist it. Apparently Steve Wozniak didn't know that. So it's a pressure fit switch with these tabs. So now I will be able to lift the PCB out easily. There we go. I just realized that the big one, the 0.47 microfarads, is starting to crack as well. So I will take this out preventatively as well and order them both up, and currently will not be using it until this is fixed. So I hope you can see it, but this one already started to go, and you can hear it when I run my nail around it. Oh, you see, it's really coming apart. So I really got there in time. And the interesting thing, if you look at the PCB, you see that it allows different footprints. And that's something that we learned in school as well. So make sure that if you have relatively rare components, that you can fit in replacements quickly so that your supply keeps going. Looked them up, what they cost. Around €1, so not really that bad. So a couple of days have passed and I got a package from Germany. Ever wondered why shipping was so expensive? Packing, packing, packing. Woo! So let's solder these in the power supply and see if the Mac is back. Apple II. I showed you before, the form factor, it fits all different types of caps. So the same type, different sizes. When you snip off the leads, you will put a massive shockwave through the solder joint, which creates hair tears that allow corrosion to seep in and work the solder joint loose again. So after snipping, you always have to reflow. I see a lot of people just snip and be done. That's not the way to do it properly. I was taught this in school by a teacher who did satellite design. These two, couldn't even see them anymore. And then the solder goes over the mount, leaving nothing exposed and keeping it safe against the elements. The new caps are in. Let's hook it back up and see what happens. Flick it on. No bangs, no magic smoke, so that's good. Measure the voltages. This should be -5. Yeah, it is a bit low, but -12. 12 and 5. Yeah, that looks good. So let's put it back. I always first put back the ground wire as a safety precaution. Now we know that we cannot forget that. And that is your primary safety for all these high voltage components. So it's back together. Let's put it in the apple. Well, let's see. And there she is, up and running again. Ready for another 36 years. I'm on my way to Oregon, and see you in the next one.